All right, hi folks, this is Larry Maslino. I'm recording a video here for chapter 14 in STAT211. I want to do a few homework problems from my labs and in particular show you how to use StatCrunch to help with efficient calculations. So let's take a look here at number one. It says a developer wants to know if the houses in two different neighborhoods were built at roughly the same time. So she takes a random sample of 6 houses from each neighborhood, and this table will have the data. So let's open up the data set here. All right, so here is neighborhood 1, neighborhood 2. I'm going to open this in StatCrunch because then we can get started with some analysis. Let me put this over here side by side if I can. All right, so here's the data set. And let's see what the first thing they want to ask is, what's the sample means? Well, really, they're asking me to just find the mean of column A here and the mean of column B. It's neighborhood 1, neighborhood 2. Well, an easy way to get StatCrunch to do that for you is go to Stat, Summary Stats, Columns. And I'm going to select here with my mouse neighborhood 1 and neighborhood 2. And then I'm just going to click Compute. And so what StatCrunch does for me is calculate the mean. So here's the mean. Here's the variance, and here's the standard deviation. So that's going to answer the mean, the variance, and the sample standard deviation questions, right? Those are all given to me in the StatCrunch output. And now the question is, what is the estimated difference of the mean ages? So they're asking me to calculate y1 bar minus y2 bar. Well, I have the answers from part A. Y1 bar is 55. Y2 bar is 48. So this difference just works out to be 7 years. All right, there's one other question that is being asked. Let's go down. It says, find the standard error of the difference of the two means. Now, there's a formula for this in our textbook, and it's kind of a messy calculation. Well, it turns out when you set up a hypothesis test for the difference of two means in StatCrunch, StatCrunch calculates the standard error for you. So I'm going to go to Stat, and this is going to be T-stats. Now, why T-stats? Well, if you know the population standard deviation, in this case, I would label that as sigma 1, sigma 2. Then you would use Z-stats. But if you only know the sample standard deviations, that's when you use T-stat. And yet we only know the sample standard deviations, right? Here they are, S1, S2. So this is where we use T-stats. All right, so I'm going to go to T-stats, and in our case, it's 2 samples. So I'm going to go to T-stat 2 samples, and we do it again here with data, right? Because we have the raw data. So it says what values are in column 1 here. I'm going to say neighborhood 1. What values are in column 2, neighborhood 2. And I'm going to leave this check where it says perform a hypothesis test. And I'm going to just click compute. And if you notice, here is the standard error calculated for me by StatCrunch. It's 4.72. All right, so that's a quick example of the difference between two means. Let's go do another example. Let's take a look at this one. This one says a market analyst wants to know if a new website is showing increased page views per visit. Customers sent to one of 2 different websites randomly. And here is the data set they're giving us. Let me open this up. And so this is the data set comparing website A to website B. And they say test the null hypothesis that the mean number of page visits is the same for 2 websites. And they're telling us, think of this as a 2-sided test. All right, well, first thing I'm going to do is open up this data set in StatCrunch. Okay, here it is. And I'm going to go ahead, and again, we don't know the population standard deviations here. So I'm going to go STAT211 samples with data. All right, I'm going to select a website A for the first set of samples and website B for the second set. Now, if you notice, they say test the null hypothesis, the mean number of sites is the same, and this is a two-sided test. Well, for a two-sided test, you have to make the alternative be a not equal symbol. So I'm going to leave this here set to be not equals. That indicates a two-sided test. And I'm just going to click compute now. All right, here's the output. So the first question I'm being asked is, what is the test statistic? Well, if you notice right here is the test statistic 0.89. Then it says calculate the degrees of freedom using a messy formula. Well, good news, StatCrunch does this for you. Here it is, degrees of freedom is 57.76. Well, then they say, part C says calculate degrees of freedom using an alternate rule that says degrees of freedom is the minimum of N1 minus 1. Now, N1 is the sample size for sample 1, but the sample sizes were 30 each. So this is going to be the minimum of 30 minus 1, comma 30 minus 1. Well, that's the minimum of 29 or 29. Well, those numbers are both the same, so the answer is just 29. So this degree of freedom is 29. All right, let me scroll down. Now they're asking us, what is the p-value? Well, the p-value here is 0.379. And then they say, what do you conclude at alpha equal 0.10? So we know the p-value is 0.379. And they're telling us to use alpha of 0.10. Well, if you remember the rule for hypothesis testing, you compare the p-value to alpha. If the p-value is less than alpha, that is when you reject the null hypothesis. But in our case, the p-value is greater than alpha. When the p-value is greater than alpha, that's when you fail to reject the null hypothesis. So we're going to fail to reject the null hypothesis. Well, that means there's not enough evidence to reject the claim, right? If we were going to reject the null, we'd be rejecting the claim, but we're not. We're failing to reject the null. That must mean there's not enough evidence to reject the claim that the mean number of page views is the same for both websites. All right, let's take a look at another example. All right, I'm coming here to number 3. So this is a similar kind of question. So again, let me open up the data table here. So again, they're showing me the number of visits to website A and website B for 30 different samples. So again, I'm going to open this up in StatCrunch because I think it's a different data set than I had earlier. So I got to open this in StatCrunch. Okay. So now I'm going to come up with a 95% confidence interval for the mean difference. All right, so what I'm going to do is go again to StatStats, 2 samples with data. And I'm going to select website A for sample 1 and website B for sample 2. Now, instead of going to this hypothesis testing section, instead, I'm going to come here to confidence interval because that's what they want in this example. So I'm going to click this button here for confidence interval. I'm going to leave this at 0.95 because they asked me for a 95% confidence interval. I'll click compute. And here is the lower limit. Let me circle it here so you can see it. Here's the lower limit, negative 1.522. And here's the upper limit, 2.71. Well, if I graph this on a number line, here is negative 1.52. Here's 2.79. And notice 0 would be somewhere within the confidence interval. So now they're asking me, is 0 within the confidence interval? Well, yes, it is. If I have a negative number on the left side and a positive number on the right side, I must have a 0 in between. What does this confidence interval tell you about the null hypothesis that the mean is 0? Well, we have to fail to reject the null here because 0 is a possible value, a plausible value, because 0 falls within the confidence interval. If 0 was not in the confidence interval, then we could reject the null. But because 0 is contained in the confidence interval, we're going to fail to reject the null hypothesis on this. All right, let's take a look at another example here. All right, let's take a look at an example here. This one's going to ask us to set up a hypothesis test for two means and come to a conclusion. All right, so it says here, companies producing and marketing new reading activities that it believes will improve reading comprehension scores. A researcher randomly assigns third graders where some will use the new activities and some will use the traditional teaching methods. Both groups take a reading comprehension exam at the end. Here's the results. So here's the new activities. Here's the control or the old activities. So I'm going to open up this data set in StatCrunch. Okay. And so let's see what the questions they're going to ask us now. All right. So it says here, do the results say that the new activities are better? Well, if the new activities are better, then the difference would be a number greater than 0, right? And notice it says, let the new activities be sample 1 and the control group is sample 2. Let me give you an example. Let's say the new activities are better. Well, then mu1, I'm just going to make up a score. Mu1 might be a score like 65. The old activities would have to have a mean less than that. So mu2, I'm just going to make something up. I'm going to say 40. Right? Because I want the new activities to have higher scores because the new activities supposedly is a better teaching method. Well, what if I take mu1 minus mu2 in my made up example? That would be 65 minus 40. Well, that's a positive number. So that means mu1 minus mu2 has to be positive. So that's why we write it as greater than 0. All right, so that's the setup of the null and alternative. They want the test statistic. Well, I'm going to let StatCrunch do the work for me. So I'm going to go stat, t-stats. Again, we don't know population standard deviations here, so I'm going to use t-stats to sample with data. All right, so the new activities are going to be sample 1, and the control or the old activities are going to be sample 2. Now, the only thing I got to be careful about is I've got to set up this drop-down menu to be a greater than sign, because that's the symbol we had in our setup for the alternative, right? I had a greater than sign here. So I have to make sure that matches the greater than sign here in StatCrunch. All right, well, I'm ready to go ahead and click compute then. All right, the first thing it's asking me is what is the test statistic? Well, here's the test statistic right here, 2.10. Then it's going to ask me what is the p-value. Scroll down here. All right, what is the p-value? Well, StatCrunch calculated the p-value for me. Here it is, 0.021. So there's the p-value. And they're telling me use alpha equal 0.05, excuse me. So our p-value is 0.021. They're telling us to use alpha of 0.05. Well, our p-value is a number less than alpha. Well, if you remember, if the p-value is less than alpha, then your decision is reject the null hypothesis. So I'm going to say reject the null hypothesis. There is enough evidence that the new activities are better. All right, folks, let's take a look maybe at one more example. Let me see if there's another example. All right, folks, let's look at an example here. This one's question 10. And it says here, in a study of new mathematics teaching methods, there's a new method and a traditional method. And here's the sample sizes, here's the means, and here's the standard deviations. So it's going to ask me to calculate a test statistic and a p-value. So I'm going to let StatCrunch do this for me. So let me go back to StatCrunch. And now in this case, notice we don't have raw data. We have summary data. So I'm going to go to T-Stats to sample with summary. And so now it's going to ask me about sample 1. Well, the mean is 57.6. The standard deviation is 31.9. And the sample size is 313. I'm getting this data right off the table. For the traditional method, the mean is 54.1. The standard deviation is 28.5. And the sample size is 280. Again, this is right off the table. All right, I'm going to come down here and click compute. And the test statistic is given here in the table. So it's 1.41. And the p-value is here, 0.159. All right, now we have to come to a decision. Well, for the decision, we have to compare the p-value to alpha. In this problem, it said assume an alpha level. Remember, significance is the same as alpha. It says assume alpha is 0.10. So for our example here, the p-value is 0.159. Alpha is 0.10. Well, this p-value is greater than alpha. And the rule is whenever the p-value is greater than alpha, your decision is fail to reject the null. So I'm going to go with this answer, fail to reject the null. There's not enough evidence, there's not sufficient evidence that students taught using the new method have a different mean score than using the traditional method. All right, folks, hope this is helpful as you're working in this chapter 14 homework.